Hi guys, I hope you're doing well where you are. So in today's video we're going to do two types of collisions. So one is elastic and another one is inelastic. So for sure you have heard about those terms before, but you don't have a clear understanding of what's elastic and inelastic. So one those terms before, but you don't have a clear understanding of what's the difference between elastic and inelastic. So if you want to learn the difference between the two, please watch the video until to the end. So you are going to learn about the elastic and inelastic. So first, let's start about to talk about the accidents. So each and every day you see accident. So what kind? So now I will teach you to tell next time when you see any accident, to tell what kind of accident is that. Is that an elastic collision or inelastic collision? So let's check. Let's take a look at this video. What happened immediately when the two car collides? You heard the sound. So if you can hear the sound, you are going to classify that as an inelastic collision. Why? Because you can hear the sound. So what's causing the sound? Sound is caused by the energy. So sound is another form of energy that's transferred. So each and every moving object has a kinetic energy. So each and every moving object has a kinetic energy. So if a collision happened and you can hear the sound, that means that kinetic energy was lost, therefore was transformed into another form of energy. Was that kinetic energy was transformed into another form of energy. And what's that? If we can write inside the brackets, so what's that? That was sound. So you heard the sound. So that sound was a kinetic energy. So let's consider that in terms of equations, so or in terms of mathematical equations. So this kinetic energy initial, the kinetic energy initial of the car is going to be greater than the kinetic energy final. Why? Because that energy was lost or was transformed into another form of energy, which is sound. So that's going to be, this is under what? This is under inelastic collision. So inelastic collision, the kinetic energy is transformed into another form of energy. Therefore, what can we define inelastic kinetic energy? So we can define inelastic collision as so it's going to be the collision where the kinetic energy is not conserved. Why? Because the conservation of energy or the conservation of kinetic energy means that the kinetic energy initial is equal to the kinetic energy final. So the definition of this inelastic collision is going to be the collision where the kinetic energy is not conserved, because the kinetic energy here was transformed into another form of energy. So that's why we had the sound. So from now onwards, any collision that you can hear the sound, it's under inelastic collision. Now let's consider the equations. So when we're talking about these collisions, the one thing that you must know is the equation for kinetic energy, which equation for kinetic energy is half mass of the object multiplied by velocity square of the object. So since in here we're talking about the kinetic energy initial and the kinetic energy final, so let's consider the collision that we just watched in terms of our diagrams. Now let's consider that here we have this car A that initially it's moving to this direction with 2 meters per second. So it's moving with 2 meters per second to the right. And here we also have VB that's moving with 3 meters per second to the left. So finally these objects collide, and then now we have this object A that's moving to this direction with a V final of 1 meter per second, and we have this one with a V final of, we don't know that what's the V final, or V final can be, you can calculate it using the conservation of energy, but we can just sign it now because I just want to give you an example. You can just say it's 2 meter per second to the left also. So finally it's going to the left, but initial was going to, since it was going to the left, it didn't change direction. So now you want to calculate, you want to check whether the collision between this car is elastic or inelastic. So since the kinetic energy is given by this, therefore here we're going to say that the sum of kinetic energy initial is not equal to the sum of kinetic energy final if this is inelastic collision. If this is an inelastic collision, therefore this will happen. And to prove that, now we can calculate it. Let's say the mass of A is equal to the mass of B. The mass of A is the same as the mass of B. So we can just simply say okay, so we can say that the equation of this initial is given by 1 over 2 mass of A V initial square of A plus 1 over 2 mass of B V initial square of B, which is equal to 1 over 2 mass of A V final of A squared plus half mass of B V final square of B. So here, since we said that the mass of A is equal to mass of B, we can also say that is equal to M. So what's what's the kinetic energy here? So the kinetic energy here, since we want to prove that this it's an inelastic collision, so the kinetic energy of this initial must not be equal to the kinetic energy of these two objects final. So let's prove that. Okay, so here we're going to say half given by half m4 squared plus half m3 squared. It must not be equal to, that's the rule of inelastic, half m1 squared plus half m2 squared. So here is clear that this one is going to be greater than this one. So if k initial is greater than k final, therefore the collision is inelastic. So here I was just showing you a simple example where we just guessing a collision and also the numbers. But in exam we are going to be given a reasonable equation where you must calculate the kinetic energy initial, and if the kinetic energy initial is not equal to the kinetic energy final, therefore you say that collision is inelastic. So now let's move to elastic collision. So it's easy. For elastic collision, you use the same proof, but the kinetic energy initial must be equal to the kinetic energy final. So there, the kinetic energy initial, the kinetic energy for inelastic, for elastic, now elastic. For elastic collision, the kinetic energy initial must be equal to kinetic energy final. So for elastic collision, the kinetic energy initial must be equal to kinetic energy final. Okay, thanks for watching. I hope you'll be with me next time.